You're watching Macro TV. We are busy with the Solow model, studying it 4 in Chapter 8 of Riehenberger. In the previous video, we discussed changes in population growth rate and how that could impact long-run changes in living standards and GDP per capita. In this video, we are going to look at productivity growth rate and what the implications of that would be for living standards and GDP growth rate. So again, we start with an economy in equilibrium. As you can see from our diagram there, we have our total production function, our graphs for required investment and actual investment, as well as our steady state capital labor ratio and GDP per capita. Then we go and we change the technology growth rate. So we increase the technology growth rate, resulting in a couple of shifts, and I'm going to do each of these individually. So the first thing that I'm going to shift here is the required investment per person. As you know, required investment per person is dependent on the depreciation rate, population growth rate, and the growth rate of either technology or productivity. Right? So directly, this increase in productivity growth rate impacts the required investment per person. It shifts to the left. Then the next shift will be a shift of the total production. Total production is a function of your capital labor ratio as well as your technology. So this change in technology shifts your total production curve to the left as well. The third shift will be a shift of your actual investment per person. This one shifts not directly because of a change in productivity growth rate, but rather because it is a portion of your total production curve. And since your total production curve has shifted upwards, proportionally your actual investment per person is also going to shift upwards or leftward. We can then look at finding out where is the new balanced growth rate, or the new steady state growth rate, or if you want, the equilibrium growth rate. And that would be determined at the point at which your new required investment is equal to your new actual investment per person. So we have a higher capital labor ratio as well as a higher income per person ratio. So the change in productivity growth rate is quite unique because it doesn't have the same limitations as what we saw when we analyzed the change in the population growth rate and a change in savings. The diminishing marginal returns doesn't have the same impact it does with technology growth rate because the total production curve completely shifts. It's not just a move along the total production curve. So, and we also don't have the other types of limitations to productivity growth rate because theoretically it could increase infinitely. And so we can absolutely use this as a way to ensure sustained economic growth into the future. And the Solow model really tries to highlight the importance of productivity growth, that technology is really the way to go if you want to ensure economic growth in the long run. Every other method has limitations, although they can be used to have growth, especially in the short run or the medium run. But if you really want growth in the really long run and sustainably increase economic growth into the future, you have to increase the productivity of your labor force. So in this video, we have looked at productivity growth rate, which in the Solow model is a very important way of ensuring economic growth sustainably into the future. And this will be the final video for analyzing the Solow growth model. Stay tuned.